All right, one last thing to do with solving our radicals is checking for extraneous solutions. Those extraneous solutions are answers that they don't exist. You find x equal to some number, but when you plug it in, you get, a square root of a negative number, or in some other situation where it's an imaginary number or not a real number. So we have to check our answers. So it says here at the top here, when you use this procedure, you should always check each apparent solution in the original equation. Now, I didn't do that for the first few sections. That wasn't the idea. The idea is to get you to be able to solve these. And we could go back and check them, but we did not. From now on, we got to check them. So I'll try some examples here of extraneous solutions and show you how to find them. And then, cross them out or eliminate them. All right, so we're solving. Nothing's changed here. Again, you have to isolate the radical. And what do you know? Number 5, it's isolated. So you do the opposite. It's 1/2 of that, of 7x plus 5, or just square both sides. So I'm going to square this, and I'm going to square this. Square both sides. Now pay attention to what I did on the left. I didn't square each term. I squared the whole right side, and I squared the whole left side. That's how it's done. It's all squared up. All right, so now, next thing I'm going to have x plus 1 squared. Now, look, you're going to have to FOIL that out. I'll write it here for you one more time, but that has to be FOILed. The right-hand side is just 7x plus 15. That's clear. That's ready to go. But you have to FOIL x plus 1. So you know how to do that. So I'll just give it right to that part is x squared plus 2x plus 1 equals 7x plus 15. All right, so now you got to combine like terms. Again, we're solving, so you had set equal to 0. So I'm going to move the 7x and 15 over by subtraction. So I'll write it here for you, 7x and minus 15. I'm going to do them both. We can do that. Minus 7x minus 15. And over the top here, we'll rewrite it x squared minus, what is that, minus 5x? Yep, minus 5x minus 14. Okay, equals 0. Now, guess what? Reverse FOIL. I think these, you can see that hopefully that 2 and 7 will get you that 5, correct? So I'm reverse FOILing x equals 0. It's a negative 5, so that means the large number is going to be negative. That's going to be the positive. Yeah. And, x minus 7 equals 0. X plus 2 equals 0. X equals 7, comma, negative 2. And you're saying, hey, man, there's my 2 answers. I'm moving on to the next problem. Well, now, wait a second. You have to put those values back in to see if it gives you a correct answer and not an extraneous answer. All right, so I'm going to try, I'm just going to try negative 2. That looks easier. I'll show you why in a sec. So I put negative 2 in the original equation. Let me zoom in for you here. Negative 2 in there. I'm going to get a negative 14 here, right? Negative 14 and 15 is 1, and the square root of 1 is just plain old 1. So then it says x plus 1 equals 1. If I subtract the 1 from both sides, I basically get x equals 0. That seems okay, right? That All right, I'm going to take the negative 2 and put it into the original equation. All right, I'm going to take the negative 2 and put it to the original equation. So I'm going to zoom into that for you. Negative 2 on the right-hand side, I'm putting it in here. Negative 2 times 7 is negative 14. Negative 14 and the 15 gives me a 1. Square root of 1 is 1. Okay, it's 1. I put that negative 2 into the left side. Negative 2 plus 1 is negative 1. Negative 1 does not equal 1. Negative 1 and 1 do not equal. So therefore, negative 2 is an extraneous solution. So get rid of all that. Again, you have to plug these back into the original equation. I'll try 7 next. 7 times 7 is 49. 49 plus 15 is 64? Yeah, 64. Square root of 64 is 8. 7 on the left side, with the 1, 7 plus 1 is 8. 8 equals 8, yes. So, bottom line is that negative 2 is not an answer. It's an extraneous answer. The only answer that's good is the 7. So that's how you do those. We'll do one more with you to make sure you got this. Trying Check for extraneous. Let's try, I'm picking one out here out of thin air. Let's look at number 12. So again, I'm going to square both sides, do something a little quicker. So square this and square that as a binomial. So I have 10x plus 9 equals, now when I do the FOIL on x plus 3, just to speed this along, I want to get x squared plus 6x plus 9. You can figure that on your own if you have to. Getting everything on the same side with the 10x, I'll subtract the 10x and the minus 9 in one step here just to keep things moving for you. We then have 0 equals x squared. Let me see here. 10x is negative 4x. Okay, there we go. Now, you have to factor this all the way so I can factor out an x. So I have 0. In fact, let me just do this for you. I have x squared. It's always nicer to see it this way. Minus 4x equals 0. I can factor out an x from both of those. So I take out an x. I have x minus 4. I set both of those equal to 0. So I have x equals 0 and x minus 4 equals 0. So x would equal 4. So those are my two answers, 0 and 4. All right, now I have to go check to make sure that they're both legit and not extraneous. Back to the original equation. 0 is always a wonderful thing to work with. I'll put the 0 in first. 0 on the left side, 0 times 10x is 0. So I have 9. And the square root of 9 is 3. I put 0 on the right. 0 plus 3 is 3. Square root of 9 is 3. 0 plus 3 is 3. The 0 seems to check out. Let's put a 4 in. 10 times x is 40. 40 plus 9 is 49. Square root of 49 is 7. So I put a 4 in there. I get a 7 on the left. I put a 4 on the right. 4 plus 3 is 7. 7 equals 7. They both check this time. So there was not an extraneous for that one. They both checked out fine. All right, next thing you got to do is number 6. It says solve an equation with two radicals. Okay, we'll do an easier one because this one gets complicated. I wanted to show you one that's a little easier. Let's look at number 13. These can get difficult. We don't have time to get to the difficult ones. Let me just show you the easy ones. All right, look at number 13. They're both are square roots. They're both isolated. So if I square both sides, this is not tough at all. Square both sides. Those square roots are gone, right? So you have 2x plus 5 equals x plus 7. The roots just go. So I'm going to subtract x. I'm going to subtract 5 from both sides, right? Minus x, minus 5. I'll do this all in one step to speed it along here a little bit. I have x equals 2. And that's it. Here's my answer. All right, let's try number 46 for an example where we have two radicals in the same equation. As you can see, it's a cube root of two separate expressions. I'm going to move the second one over to the right by addition. So if I add the cube root of 8x plus 15 to both sides, the negative one will go away. So just, again, not much room here, so just by adding it, the sign changes. So then you have this. You have cube root of 12x minus 5 equals the cube root of 8x plus 15. Again, it's positive because now you added it to both sides of the equation. And, zero's gone. All right, so they're both cube root. And if I just cube or both sides, so 3 power, oops, and a third power here, the cube roots are gone. And all I've left are the expressions that were inside the radical. And I got some nice easy math then, right? So 12x minus 5 equals 8x plus 5. I'll subtract the 8x, add the 5. Again, I'm doing 2 steps for 1 here to save us some time here, my friends. So minus 8x, minus, no, leave that there, plus 5, minus 8x, okay? So I have now 4x on the left. On the right, I got 10. Great, another fraction. Divided by 4, x is 10 fourths. And there you go, my friends. That's it. Enjoy.